Hi, in this video series we will talk about operating systems, and I will be using these PDFs that were made using this book called Operating System Concepts, and I think that this video series will be about 30 videos and they won't be too long videos. And in this series we will talk about what are operating systems. We're going to talk about computer system organization, computer system architecture, operating system structure, operations. We're going to talk about process management, memory management, storage management, security and protection, and if we have time, we're going to talk about the rest. So let's get started with the main question. What is an operating system? Well, I'll digress from this PDF a little bit, and I will talk about how way back in the day they had these computers that was mostly hardware than software. They had these punch cards where you would put the information, the code, and then you would run it through the computer. I got this picture online. You run it through a computer. So if you want to do 8 plus 10, you would code the information for plus operation. You would code the information for 10, and then you would, feed them one by one to the computer. These kind of routine tasks were done by people called operators. So they would operate the computers and run the program that needed to be done. But these tasks were meaningless, so they decided to make a software that could just do this. Its whole purpose is to do these routine menial tasks of operating the computer. As it says here, operating system is a program that is an intermediary between a user and the computer hardware. And what it does basically is to execute programs. It decides which resources to allocate for programs, it decides how to run it, which one to run first, etc. So what it does is execute programs. It is try to make the computer, more convenient to use, and it tries to do that in an efficient manner. Efficiency matters because you don't want your computer to allocate a ton of resources for one program and then for the rest of the programs to be laggy and slow and not be able to run correctly at all. You don't want that. So that's an operating system. It's basically a software it's software with a purpose, and its purpose is to kind of be the middleman between the users or other softwares and the hardware of the computer. So during this course, we will talk about why we want operating systems to be efficient. For example, let's say we have 10 programs that we want to run. We do have the resources to run each one of them, but we need to make it so that everyone gets enough resources, and how we can do that and how we can code that system, the software. Okay, so now let's talk about some basic keywords that we're going to use throughout this course. First one is hardware. So hardwares are the components of the computer that you can see and touch. They're physical, and they provide basic computing resources. For example, CPU is central processing unit, and that's where the processing happens. It executes the programs and the actions and whatnot. So memory is, when we say memory, we mean RAM, random access memory, where you go to, you've probably seen it in a computer when you're buying one, or when you're just browsing, you will see that 16 gigabytes of RAM, like 32 gigabytes of RAM. Those are what we will refer to when we say memory. There's also secondary memory, which would be like hard drive, SSDs. But when we say memory in this course, we mean random access memory, RAM. And there's input-output devices like keyboards, mouses, speakers, devices that are not technically needed to run the computer. There are computers with input. Your car may have a computer, but it doesn't have a keyboard. There are computers on the satellites that also don't have a keyboard or anything, because it's not needed for that. Operating system is the next keyword, and it's what we talked about. It is this layer between hardware and software, the other programs that we use. And operating systems create sort of this abstraction for us as well. Operating systems also create some type of abstraction for us. So for example, when we click on a program, when we're running programs, the computer doesn't tell us how it's running. It doesn't say like, oh, I'm gonna run this in the GPU, I'm gonna give these resources, when we're downloading something, I'm gonna allocate this sector of this disk to this program. It doesn't tell us, it just does it. For us, we don't have to think about that. It's automatically done by the operating system. Applications and programs, those are the software that we run, like Microsoft Word, Google Internet Explorer, your games, or anything. These are application programs, and these application programs don't have direct access to hardware of the computer. When you're playing on your computer and you hear a noise and this game makes a sound, that sound is not communicated from a game to the hardware. Game communicates with the operating system, so the applications communicate with the operating system, and operating system communicates with the hardware. So this middleman. And users are us, people who play the games or just browse through the internet, machines or other computers. So machines can also be interacting with other computers, sharing some information. And so machine, for example, a signal detector can talk to another machine, like when you're drying your hands, it sees your hand and it communicates with the dryer so that it starts blowing. Or we have a concept called Internet of Things, where your fridge can be a smart fridge and it can detect that it doesn't have milk, and so it orders some. And there's a communication between these two machines, or multiple machines at the same time. So as we can also see from this diagram, computer hardware is the lowest level, and then we have operating system that controls the computer hardware, and we have system applications that are above the operating system, like compilers, text editors, assemblers and whatnot, or the other programs that you're using. They don't have direct access to computer hardware. Obviously, there are some programs that do have direct access to hardware that kind of bypasses the operating system, but it's not part of this course, so we don't need to talk about that. Operating systems, in this case, also you can imagine that sort of serves as the security, right? Because you don't want all of your applications to control your computer hardware, right? That would be a security breach. You don't want that, so you want operating system to kind of do that for you. Okay, so as we mentioned before, operating systems make the hardware easy to use. We care about the ease of use. We don't care about how these resources are utilized in the computer, but we want the computer to keep the users happy and not worry about other stuff. And so what they do is they optimize the usability, they optimize the battery life. There are also operating systems in cars that make it easier for us to use the car without having to worry about stuff, and increasing the comfort, increasing the security of the car. We can also say that operating system is a resource allocator. It allocates the resource, manages all the resources, but it also is a control program that sort of controls the user, the programs, to make sure that they're not causing any other problems or errors. Just like as it says here, there's no universally accepted definition of operating systems, but basically what we explained is the general gist of the operating systems. Is it an operating system's job to start up the computer? Not always. There is these BIOS, basic input-output systems, that start the computer up. When the computer first starts, it has to know itself. It has to know if there's memory, like RAM, and how much that is, how much memory it has, how much clock speed it's running at, the secondary memory, how many gigabytes of disk drive it has, and etc. It has to know that. And there are some certain protocols that were given to the computer. When you first start it for the first time, it tells just read this sector and load whatever there is to the computer, and that loads the operating system. It's called the kernel, and that's the part of the computer that always runs, that's always running, and that kernel kind of loads the operating system, and then the rest of the things also start running. So firmware is manufacturers these firmware of how the hardware will run. Each manufacturer has its own, but those firmwares then connect to CPU, but we will talk about how that happens later in the course. And as we said, the kernel starts, it loads the operating system, and it starts the execution. And around the kernel, there are shells. They kind of try to resemble a fruit, sort of. There could be shells that protects the kernel. I won't say that. That's why it takes so long for computers to kind of turn on, because they have to kind of load up the operating system and get to know the computer. Computer gets to know itself and what components it has. But obviously nowadays we have laptops that boot up really fast. They're not really doing that whole thing. because they're always on even when you turn it off. It's always on unless you it has no battery or anything. So basically we have the system, the CPU communicates information to disks. The USB controllers, they control mouse, keyboard, printers, and graphics adapter, which then communicates information to the monitor. So CPUs and memories, these are like two things that you need to have the computer running. And it is very efficient because you can make computer do anything you want without having to specifically change the components of the computer. So when electrical engineers want, door automation, they use a different electrical system. When they want to have a sensor, blow dryer, dry your hands, they use a different system. But for computer scientists, they came out with this structure which can basically do anything. You can put a computer with the same components on a car or on a door or a satellite with the same components, but the software and the operating systems will manage it and make it do different things, different tasks. We already talked about these. We can talk about the interrupt. So interrupt is basically this operation that causes an interrupt in the CPU. When CPU is doing something else, it interrupts and it starts to run another execution. It starts to execute something else, some other instruction. It can come from input-output devices like keyboards, mouses, or it can come up from another devices. What it does is to interrupt the CPU and start executing a different instruction. So our job here is, with the operating system, is to always make CPU busy. We want CPU to be as busy as possible. We don't want CPU to be just sitting and not doing anything when we have 10 programs that we want to run. So we want to use as many time, we want to use CPU as much as possible and as long as possible. And so there are some operating systems, for example, that have idle processes for CPU to not just do nothing. You always want to run something. And we're going to talk about why that matters. A vector that is created to do how this interrupt is going to work. So the transfers usually control the interrupt service routine generally through the input vector, and it contains the addresses of the service routines. Like, for example, data structures, they're like, oh, I will be they get into this line, first to run, and then the other one. And so, but we also don't want to interrupt it consecutively, interrupted in a very short amount of time. You're trying to do something and then interrupted once and interrupt again. You'll not be able to complete that task. So there's also lags you can add in between to make sure that there isn't that problem, to not have that problem. There is also interrupts can also be disabled. When let's say that you're trying to do something, there's an interrupt, and then you're trying to do that again, and there's an interrupt again and again and again. It can lock the CPU, so you can actually add some locks to disable the interrupts for being processed. A trap is a software-generated interrupt caused by an error or a user request. There are some different traps if you look at the manual. So in the manual of the CPU or AMD, whatever you're using, whatever CPU you're using, they have this. In the manual, they have this list of interrupts and what it means. So if you get this interrupt, it means that. If you get this interrupt, we can say that operating systems are interrupt driven. So basically, interrupts are the messages between the operating systems and the hardwares. That's how they communicate. We have different types of interrupts, polling and vectored, but we don't have too much time. We will get into that later. I'll just quickly show this. This is a diagram that shows when the CPU is working, and then there's this transfer from input-output device, and when the transfer is done, there's a little interrupt here, and then it goes back to doing what it's doing, and it goes back to working again. And this is it for this video. Thank you for watching.